The structure of a molecule like water, H2O. So the first step again, number of valence electrons. You have 2 hydrogens and 1 oxygen. The valency of each hydrogen is 1. The valency of oxygen is 6. It's in groups. 6 total electrons to spread around the structure is 8 electrons. Then, since we have only hydrogen and oxygen, the first rule of drawing loose structure is the hydrogen should be terminal. So I put oxygen in the middle, even though it's more electronegative, and we put hydrogen outside just based on the first rule. We know generally you want to put the center atom to be the least electronegative. Okay, step number 3. Step number 3 is to at least form a bond by giving lone pair of electrons shared between the two. Okay. Now so far we've used 4 electrons. Out of the 8, we are left with 4 to account for. Now we can't put the extra electrons on either of the hydrogens because those are stable with a duet. This hydrogen has 2 electrons, this hydrogen has 2 electrons. The 1s2 is filled. So the oxygen has 4 electrons, it's missing 4. So we're gonna go ahead and give it the remaining 4 electrons, and we will have accounted for the 8 valence electrons right here. We will have accounted for them here. Right? So now the next step, of course, is to draw the bond where it should be. Draw the bond where it should be, and then the lone pairs where they are. Now, in a coming class, I will explain to you valence shell electron repulsion theory, where even though this is the complete loose structure of water, it has to be bent. It has to have a bent configuration because the 2 lone pairs repel. The 2 lone pairs repel. These 2 lone pairs repel the electrons in the bond, so it makes the water molecule to have a bent structure, bent geometry. Okay, so because halogens